Today we are going to start with a new objective regarding the function. It talks about the continuity, so we are going to talk about the continuity of a numerical function and how can I say that a function is continuous and what's the relation between being strictly monotonic and continuous. First of all, what's the meaning of continuity? First, you have to know that we study the continuity of a function at a point. So we say that a function f is said to be continuous if and only if the limit for this function when x tends to a, it's the same as f of a. So the continuity of a requires the continuity of f to the right of a and to the left of a. Or in another word, the limit of the function when x tends to a plus, it should give me the same as the limit of the function when x tends to a minus, and also it's the same as f of a. As an example, we have here this function f of x. It's x plus 1 when x is less than 2. It's 2x minus 1 when x is greater than or equal to 2. We're going to study if it's continuous at x equals 2. First of all, you have to know that this is a minus because it's x less than 2, so it's study for 2 minus, and here we have x greater than 2 or equal, so this is 2 plus when x tends to 2 plus, and this is f of 2. Okay, now f of 2 we should replace in this one because this is x equals 2. When you replace x by 2, you get 2 times 2 is 4, 4 minus 1 is 3. Now we are going to find the limit when x tends to 2 minus and the limit when x tends to 2 plus. They should also give me 3, or else it will not be continuous function. The limit when x tends to 2 minus, we replace it with the first one, so it gives me 3. 2 plus, we replace it also here, so it gives me 3. So limit when f of x tends to 2 exists, that means this function is continuous at 2. So in order to study the continuity of a function, if you have the function, you have to do limit for f of x when x tends to 2 minus, 2 plus, and f of 2, you should get the same answer. Now we're going to study the continuity over an interval. So we already learned how to study the continuity at a point. Now we're going to study if a function is continuous over an interval. So we say that the function is continuous over an interval if it's continuous in all its points. But of course, I'm not going to find the continuity of all the points, including the interval from a to b. That's why you have to know, first of all, that the polynomial, the rational, the irrational, and the trigonometric functions, they are all continuous over the interval I contained in their domain. So they are all continuous. If you look at the first figure, here we have a polynomial. Okay, this is the drawing of a polynomial. Okay, its domain, it's from minus infinity to plus infinity. This function is continuous over this interval. And the second figure, as you can see, we can't say that this function is continuous because it's not continuous from minus infinity to plus infinity, while it's continuous from minus infinity to minus 2, this function, and it's continuous from minus 2 to 2, and it's continuous from 2 to plus infinity. Okay, so it's not continuous from minus infinity to plus infinity, but it's continuous along every part of the interval. Properties of continuous function. Every continuous function, it has its own image. So this image is related to the interval. So if a function, as you can see, for example, in this figure, we have this function, which is x squared minus 2x. It's continuous over R. Okay, so if it's continuous, then it has an image. Suppose we take a part of the interval, which is from 2 to 5. Okay, from 2 to 5, as you can see, this function is increasing. It's increasing. You can see it, right? So from 2 to 5, then the image f of I, we say f of I, which is the image of the function, it's from 0 to 15. How can I find these numbers? I just replace the 2 by the function, so we get 0. Then I replace the 5 by the function, we get 15. So if it's increasing from 2 to 5, then its image from 0 to 15. From minus 3 to 0, as you can see, this function is decreasing. Okay, so it's decreasing from minus 3 to 0. We replace the function by minus 3. What do we get? We get 15. So we put it the next one because it's decreasing. And we replace the 0. We get 0, so we put it at the beginning of the interval. So if the function is increasing, okay, the image, it's f of 0, f of 15. But if it's decreasing, then it's f of 0, f of minus 3. I will write it so it would be clear for you. So if this in this interval it's increasing, so we just do f of 2, okay, and f of 5. If it's decreasing, we switch them. So we find f of 0 first, then f of minus 3. And this is the image. Now, the sense of variation of a function. We say that the function is defined and differentiable over an interval I. If the derivative is 0, then the f is a constant. If the derivative is positive, then the function is increasing. If the derivative is negative, then f is decreasing. If the derivative is strictly negative, then the function is strictly decreasing, and if the function is derivative is strictly positive, then the function is strictly increasing. So we say that f is said to be monotonous over I if f prime doesn't change its sign. So if f prime it doesn't change its sign, then the function is said to be monotonous. In this case, f is increasing over all I and also decreasing over all I. So it's not increasing then decreasing. Okay, so if the function didn't change its sign, means the function is either increasing or decreasing all over the interval. Now, what if the function it's not positive all the time or negative all the time? So if the derivative is increasing then decreasing or decreasing then increasing, that means that the function is changing its signs. So it has a local extremum. Local extremum could be local minimum or local maximum. If the function is increasing then decreasing, means it has a local maximum. If it's decreasing then increasing, it has a local minimum. Okay, so if the function or the derivative is not it's not constant or it's changing its sign, means it has a local extremum. Now, just to make a quick generalization, so if f is continuous and strictly monotone over an interval, then it has an image. We say that f of I is the image of the interval, and we have f defines a bijection of I into f of I. So if f is continuous and strictly increasing, as I told you before, and the interval is from a to b, then the image is f of a, f of b. But if the function is continuous and strictly decreasing over ab, then we switch them. So we find f of b, then f of I. If f is continuous and strictly increasing, but it's not closed over its domain, as you can see, so it's a, b, then the image is f of a, l, where l, it's the limit of f when x tends to b. So we find the limit at b, because it's open, it's not closed. Okay? Now, what's the meaning of bijection? Bijection means that f is a mapping and all elements of f of I admit one and only one antecedent. So if you look at the first figure, it's increasing. This is a bijection because when x1 we have, for example, y 2, for example. So every x it has is its own y. Okay, while the second figure, it's not a bijection because, for example, for y equals 3, for y equals 3, I will put a line. You can find 2x, okay, 2 antecedent. So this is not a bijection. Okay, so in order to have a bijection, every x should admit only one y. So now we're going to study if the function is increasing or decreasing to find its image. Okay, so we have a function radical x plus 2. Its derivative is 1 over 2 radical x plus 2. So this derivative is positive for every x. Then the function itself is strictly increasing over its interval, which is -2 to plus infinity. So we say that f is continuous and strictly increasing. Then it admits a bijection. And how can we find the image? We do the limit. Both of them are limits because both of them are open intervals, and we are going to find the limit of at -2 first, then plus infinity because it's increasing, so no need to switch them. So the limit of f when x tends to -2 is 0, and the limit of f when x tends to plus infinity is plus infinity. Another example, we have the function f of x equals -x over x plus 3. The derivative is negative for every x. Okay, so because it's decreasing all the time, it's negative, so the function is continuous and strictly decreasing over -3 to plus infinity. So it contains an image. We do the image of both of them are limits because both of them are open. Okay, and we do the plus infinity first, then the -3 because it's strictly decreasing, so it's switched their positions.